Hey folks, Quill18 here, and welcome to another episode of our mostly civilized hex engine. There are a couple of things I think we're going to tackle in today's video. The first thing we're going to do is we're going to follow up on some of the work we did during the live stream for the Pathfinding, and I'd said at the end of the live stream that what I was going to do probably is revisit just this find path function and turn it into something that uses generics a little bit, because right now we have this slightly awkward thing where find path requires tiles that implement this IQ path tile interface over here, which works perfectly fine. But that's also what the type of the array that it returns. And there's not there's sort of this awkward little conversion that has to happen. This is in our unit code over here, in our dummy pathing function for our testing here. We find the path from our current hex to some other hex that's 6 tiles over to the right. I mean, again, it's all hard-coded in here for testing. But the big thing is that it returns this array of path tiles, IQ path tile array like that. But we really want them to be our actual hex class objects over here. So what we do is we do the system.array.convertAll, which converts we do a cast of each individual item in this array. We cast it to a hex, which works because we know it's supposed to be a hex, although we're semi-taking things on faith here, that this is not doing anything really weird. And then we're putting those into our actual path hexes array, which is ultimately what we want. I would like it much better if this qpath.findPath function just returned an array of hexes outright. And we can do that. Now, but what we don't want is the actual qpath library here that we've developed to have any idea or be interested in any way whatsoever as to what classes are being passed to it, what the object type of things are being passed to it. All it cares is that it implements this particular interface. But we've used generics before. If this is new to you, you've seen mostly when we use generics is, well, here's an example right here, the Q hex, or say list hex. What we're doing here, list of hexes. We're asking for, list is a class that holds a list of things, and we are telling it here that the list, the stuff it should hold are these hex type objects. But you can put in any class name over here, and list will happily keep a list of any type of class. And we can do the same thing over here. So what we're going to specify for our find path over here is we're going to say that so we're going to define this as generic. So we're going to put this little angled brace over here. And traditionally, you would use the letter T as the placeholder over here. So what we've done at this point is we've said that find path, when you call it, you're going to have to specify some sort of object type in between these angle braces. So right now, if we were to do if we were to flip back over here, let me stop the program from running, we should get an error. There we go. The type argument for this is missing. Okay, so now we're getting an error that when we try to call this find path function, it's no good because we haven't specified the type, the class for this generic function. But the same way that we use it with our list, our collections over here, we can say, find path, you're going to be doing something with this hex class. You don't need to know anything about it, but you're going to be doing some stuff with this hex class. And now, I believe, there we go, it'll compile. We've got these warnings over here. We got a couple of variables that we're not actually making use of now. We may or may not just remove them, or we may start using them later on. Let's not freak out about that. The unbreachable code detected is simply because right here, movement rules like Civ6 is we defined it as a constant, and it's set to false right now. So this area literally can't run. We can implement it slightly differently later so that we don't actually get a warning about this, but that's okay. Right, that's not a problem in any way whatsoever. Anyway, this code, where are we? Right over here. Oh, this is in unit code. Hold on. Scroll, dummy pathing function. So this code now compiles happily. It doesn't do anything yet, but we now have the ability to communicate that we've got some sort of class type here. Now, ultimately what we want to do is, so this T is traditionally used as the placeholder for these templated functions, but it could be anything. This is like some class type that derives from or implements IQ path tile is really what we're looking for. And what we can do is we can replace some of these things with this class type name. So we can say what we're actually going to be doing is we're going to be returning an array of some class type that implements IQ path tile. And our start tile and end tile are both some class type that implement. Okay, we're going to just use t's, and that's going to be perfectly fine. Okay? So we've got a generic class here, t. Now, if we try to compile again, it's not quite going to work. And why is that? Because the problem is, there are lots of places where we're trying to do things, right? Where we're trying to pass things in and out of things. And, right here, okay, this particular warning is actually a great example of the problem, okay? So this find path is perfectly happy to take a couple of objects of some type, and it's presumably going to do something with them, and then it's going to return an array of that type of class. This is a perfectly valid signature for this, but at some point we need to use these start tile and end tile objects, for example. For example, QPath A star actually needs, in its constructor, it needs to be passed an IQ path tile object of some kind. So we need to make sure, and this is what we don't have yet, we don't guarantee that start tile and end tile implement IQ path tile. But one of the neat things with these generics is that you can require them to fit a certain profile. For example, we can say where t implements IQ path tile. So again, we say t can be any kind of class whatsoever as long as it implements IQ path tile. Now all of a sudden it's very similar to what we had before. Because before we were passing in a hex object over here, right? In our call-in unit, we were passing in a hex, but hex implements IQ path tile. And in our previous function call, which looked like this, it was perfectly happy to take a hex in here because hex was sort of derived from IQ path tile. So that was okay. So we're kind of back where we were. In fact, I believe now this will once again compile without errors. Almost. Almost. We'll get back to this in a second. We are almost there. Actually, that's kind of funny that there's an error there. But so we don't know what class T is, but we can guarantee that it implements IQ path tile. And the end result now is that we can return an array of the right type. So now all of a sudden in unit, this is actually going to very happily return the array of path hexes. We should not get an error here anymore because find path actually is promising to return an array of whatever this class is. So if we go back over here, we shouldn't get an error on that line. But now that's interesting. That is very interesting that we get an error here. Because resolver.getList, right, or resolver or QPath A star, this is saying that it returns an array of IQ path tiles. Yeah, that is true. That would be an error, right? Because this is an array of IQ path tiles, but what we're trying to return is an array of whatever t is, which in this case, t is hexes. And we can't automatically, we're back to the same problem we had before, right here. We can't explicitly convert an array of IQ path tiles to an array of hexes. So I guess we're going to have to genericize QPath A star as well in exactly the same way. I didn't think we'd have to do that, but that's okay. We are, oops, not here. So we are going to say that our class here is also, when you instantiate a copy of this class, you're going to have to specify some sort of class type. And again, what we're going to do is we're going to specify that T has to be an IQ path tile type over here. And then we can go again and say, so that's a T, that's a T, this is all fine and legit, this is a T, this is a T. And again, all our code will still work because we're guaranteeing this. Can I put a T here? I guess I can. Yeah, that's fine. So basically, everywhere we put IQ path tile instead of being IQ path tile, we can actually just replace it with T. Boom. Because T is an object that implements IQ path tile. And I don't know, T does not contain a definition for get neighbors. It should. Circular constraint dependency. Where? Oh, oops. IQ path tile. Find and replace. Sometimes does bad things. Okay. T requires one type argument. Okay, yeah, that's fine. So we've now been told that you cannot instantiate a QPath A star without specifying a template. So in this case, the template will be T, right? This is inside of QPath. It doesn't know what a hex is. It's just going to say, we're going to use the same. So this find path function gets called with some sort of class in T. So we're going to say for a QPath A star, we're also going to use T. Again, the important thing is that T is something that implements IQ path tile. Okay. And that's interesting. There is no automatic way to compare two T's. Really? To see that they're the same reference. Well, because again, it's so generic, it really has no way to 100% guarantee that they're exactly the same thing. So I guess, well, there's a couple of different possibilities here. We could override the equality symbol. We could also put in a, well, something we do have to do something in IQ path tile. We have to say, all right, there has to be some way to compare two hexes to see if they're the same value. So what we can do is we can override the comparison operator, which, let me just double check the syntax for it. C# override comparison or comparator. Is that the right one? Yeah. Double equal signs is all I want. So it's got to return int that's basically the same. Actually, we might be able to get away with something here. Because right now, where are we? Right over here. So how do we check to see if this current tile is the end tile? There's a few different ways of doing it. And really, what was going on here before is we were just checking to see if they were both referencing the same object, which we should still be able to do, because we should actually be able to say system.object.reference equals current end tile. This, I believe, actually will work. And it does. So this is just asking the system, hey, do current and end tile both point to the same object in memory? Okay? And for us, the way we've implemented this, that is perfectly fine. However, there might be, if at any point we end up in our algorithm here, sort of copying tiles or instantiating new tile, there's other ways to check to see if tiles are exactly the same. For example, we could check two tiles are the same if their Q, R, and S is the same. It is conceivable that we could instantiate two instances of hex, but they're both supposed to represent the same space, and we could do a comparison over here, in which case we could override the equality operator and do something of that nature. But I don't know. I think that would be kind of... I don't think that would be necessary. Well, we can get to it if we can get to it, but really all we care about here is to say, hey, does current and end tile both point to the same object in memory? In which case, do this. So now, all of a sudden, we are back to compiling, and we haven't made any logical changes to our code at all. All we've done is replaced all references to IQ path tile with this T marker over here. And the whole reason for doing this is because we want to be able to return an array of the final proper class, i.e. an array of hexes as opposed to an array of IQ path tiles, just to remove this really awkward reference here. Now, if it was just one time, it wouldn't really be a big deal, although this isn't especially fast. I mean, it's not super slow, but it's overhead, and actually, we're very likely to have to do a lot of these conversions from this pathfinding thing, especially as we're mousing over things. And there's a lot of places where we're likely going to want to do this pathfinding call. It's going to happen in the AI code. It's going to happen in our user interface, which is what we're going to be working on next, where i.e. you select an object or a unit, and then you like hold down right click and move your mouse around, and it keeps drawing the path to wherever your mouse is at that time. So we're going to do a lot of calls, and it's both slightly more efficient, but also just a heck of a lot more convenient to not have to do this conversion step, which is just awkward and weird and bizarre. So we're going to do that. Now, what we might want to do, so this, well, let's give it a test first of all to make sure this is still working okay. So we're going to hit play. So we've got our dwarf over here. I guess I can shrink this down because we're not really using the game view yet. And if I hit space bar, what happens is he does a pathfinding 6 tiles to the right. Oh, not spacebar. P. There we go. P does pathfinding 6 tiles to the right. He gets pathfinding of length 9. So now if I hit space, he should start to move around that path. He goes around the lake because you can't go through there. Goes on that hill. And because either way, he's going to use 2 movement to either go to here or to here. Ends up the same rate there, so he goes around this hill, although that's, again, something we might tune just to make it look, because it looks a little funny to go sideways, and in fact, it's better to be on a hill because it's defensive and gives you better vision. So we'd actually like him to prefer to be on top of the hill rather than go on the flat terrain over here, but that's a very easy adjustment to make. And then eventually, there we go, that's his final destination right over there. So the pathfinding system still works, it's just a little bit cleaner now. All right. Good. I was going to do... What else was I going to... Oh, set path over here. If... it's possible for this find path to return nothing, to return an empty path. And right now, the system will try to work with that. Basically, what we should do here, it's possible for Hex Path to be empty. Now, I still think it's probably fine to still start a quote-unquote new queue with this path. If Hex Path is empty, then we'll start with an empty queue. And I think that's okay. I mean, regardless, we need to override the previous Hex Path, right? So what we could do is something like, oops. First of all, I probably shouldn't use the same name twice. It should be something like Hex array or something, just to make it a little bit more clear that one's one, one's the other. So what we could do is wrap this whole thing in if hex array equals null or is empty, like has a length of 1, for example. It'll never be null. Well, it should never be null, but it'll never be null from our particular code over here. So if it's empty, then instead we just, set hex path to null? And then everywhere else we've got to check to see if it's null before we try to pull things out of it? No, I think it's perfectly fine. If hex array is empty, then we just create an empty queue, and then our end result is hex path is an empty queue, which is what we want. If hex array has a length of 0, we want hex path to be a queue that is empty. So this happens automatically, but this will throw an exception if we try to dequeue from something that is empty. So we'll put a little wrap around here. If hex path dot count is greater than 0, then and only then do we try to do this. Because this part of the system should be able to respond to an empty list A-OK. In fact, we might want an extra little function here that's something like public void clear hex path or something like that, right? And this literally will just do something like, well, I think at this point we can probably just set it to, again, a new queue of hexes, but an empty one. There we go. So we could have called this or that or whatever, but there we are. So we got a little clear hex path in there, because that might come up. Probably, because there probably is going to be a UI button to say cancel all queued movement, for example. So we've got that. All right, so let's start working on the user interface. What I want to do here is I want to be able to, first of all, where the heck is our little dwarf? I don't remember. There's our little dwarf over there. So I want the main camera to start in this position. So what we can do is copy the transform, paste the values in there, so when we hit play, I mean, we could write code and stuff in there as well, but there we go. So now what we've done is we just make sure the camera is centered on our dwarf to start off with, which will make it a little easier to test. So what we want to do is we want to be able to click on a tile, okay? And when we click on a tile, what we should do is say, hey, does this tile have a unit in it? It does, then we want to select that unit. We could do it a couple of different ways, but I think that logically, I think that's perfectly fine. I guess there's a possibility if I sort of click here, it might actually sort of click on that tile back there, but I think that's pretty unlikely. The other thing you can do is actually give feedback. As you move the mouse around, we could like highlight whatever tile is under the mouse at any given time, just to make it really clear where the heck you are. I don't think it's much of a problem. But what I want is the logic of, I click on this tile, it notices that there's a unit in this tile, so it puts us in the unit is selected mode. Then what I want to be able to do is, and we already distinguish between dragging and clicking, right? See, mouse up, click. If I just click, it says mouse up, click. If I press and hold the left mouse button, drag the camera around and let go, it says, it confirms that we are canceling the camera drag, but notice it does not send the mouse up click signal, which is really good. So if I do click on this tile, I want to then be able to hold down the right mouse button and see the path that the dwarf would take to whatever tile is under my mouse at any given time. And then when I release the mouse, that's when I want to feed the path to the dwarf. So that should be relatively fine. So let's go and close these tabs for now. And we are going to be working with our mouse controller over here. So our mouse controller's already got a fair amount of logic put in. Its default mode is to run in this detect mode start function. So this will run every single frame until we enter some sort of mouse mode, and then our logic will tweak over here. So this is particularly the code we're interested in here. If get mouse button up, that's our click. So this is what happens when we have clicked on a hex. Now, I think one of the things that we are likely to want to know in almost every mode is what tile is under our current mouse. So that sounds like we probably want a little helper function for that, because we don't have that right now, right? No, we don't have anything of the sort. We've got the ability to find out where the mouse is on the ground plane, but that's it. Do we have colliders on the mouse? Because we can just Raycast and see what hex we hit, right? That's probably the simplest way to do it. Mouse to ground plane, yada, yada, yada. Because do we do rays? Right, we get the rays, but we don't actually do a ray cast with it. Okay. I mean, so what we could do, now you can do the math, right? If you know where your mouse is, which is what we do, right? We say, if we shoot a camera out from the camera through our mouse pointer, we want to know at what coordinate the mouse is on the ground plane. We can math out which hex is there from that. And ultimately, in the end, that may be what we want to do. But I think our life will be a lot simpler early on if we simply go and do a collision run. Although it means we need to put a mesh collider on our hexes. Are we okay with that? I think we are, because I think we're going to want, imagine later on we have like explosions or debris or something like that that can like tumble onto the ground. I think it's entirely reasonable to think, hey, wouldn't it be great to have colliders on our hexes so that we can check for that sort of thing. We'll have to be relatively modest, I would say, with our with how we run our collisions so that they don't overwhelm the system. But I think that's perfectly reasonable to do. So in our hex prefab, we have a hex model. Let's go and put it in the game world just to make it a little easier to visualize here. Right, we've got this. It's got a model. It's got a mesh renderer. We can throw on a mesh collider on there. By default, it will grab the same mesh that's in the mesh filter on this object, which is very handy for us. So now we've got a mesh here. One of the things we can do to optimize this is we can specify that it's convex. Now that's interesting. It turns into a box shape. Because there's certain things that can only collide with convex meshes. Maybe we'll hold off on that. But if you have an object that just has a mesh collider by itself, the physics system assumes that this object doesn't move. And in practice, in our system, when we scroll when we move the camera, when we pan around, say east-west, right, and we get the cylindrical world, we actually do move the tiles around. So I think we'll actually also need to add a rigid body on here, but it's going to be a kinematic rigid body, i.e. it is never affected by the forces of physics. So if we do those two things, we now have these hexes that are ready to be physical. Again, this might not be the correct thing. We might run this and find out that this kills our performance. I guess we could find out at this point. If I hit play over here, Our frame rate is still over 300 per second. If I pan around, it slows down a little bit because we're doing some calculations. At some point later on, we will go ahead and do, probably run our profiler to find out, where our bottlenecks are. They could become all kinds of different things. For now, we haven't completely destroyed the computer, so I'm satisfied at this point that this is going to be a-okay. Which means now we can use some very handy little functions here to say something like, how about we get a function that returns a hex and it's something like mouse to hex, just to echo what we have here with mouse to ground plane, right? And we don't even need to take in the vector 3, which is kind of interesting. We could, even here, we don't need to take in the vector 3. We might end up changing that, but mouse to hex is going to do our very, very common job, which is we take our input.mouse position, we turn it into array, then we're going to use physics.raycast, which is going to take our mouse ray and is going to return some hit info for us. So we need a raycast hit info. We don't have to instantiate this because it's just a struct, but we do pass it as an out. The idea being that the physics raycast system will fill in info about what it hit in here. Physics.raycast returns a boolean if it hit anything, so we just do a check. If physics.raycast returns true, then something got hit. So the question is, what was it? And then we can find that out from hit info. One of the things we're going to do right away, though, is consider, the code doesn't return values, that's fine, is we're going to consider, and this isn't going to be premature optimization, we're going to consider our layers here because it's something we're definitely going to want to do for a multitude of different things. We are absolutely going to want our HexTiles to be on their own layer. It gives us a bunch of control over rendering later on, and more importantly, it gives us a bunch of control over our physics at this point. So our hex prefab, we're going to go and change it. And it's very tricky. Whenever you add a layer here, all it does is open up the tags and layer screen. So if you put in a layer, you still have to remember to go back to the object and actually give it a layer. So we're going to give this the hex tile, yes, change all children. So the hex prefab game object itself, as well as the hex model, and right now the chord label, which is just in here for debugging, is all part of the hex tile layer. And what we're going to want to do is we're almost certainly, with this raycast, going to want to only raycast against things, right? This one here. No, there's so many variants of raycast. Probably this is the one we're gonna have to use. Only against things that are on a particular layer, because then we get to ignore a bunch of different objects. The only thing we want to hit with this raycast are the hex tiles itself. We don't want to hit UI elements, objects, various like visual effects. I mean, there might not be that many things with actual colliders, but let's try to make sure. So this version does need a distance. Now, our distance, we don't actually care. We can just say, listen, to infinity is fine. And then it needs a layer mask, which is an integer in this particular situation. Now, we've looked at this before. Layer mask really wants to be a binary value. Okay, so it's going to look like something like 0.000000001 and it's to say, because each layer, if we take a look over here at our, I guess I could have just done it the other way. Tags and layers over here. HexTiles is 8, which means it's the 8th bit from the right. So there we go. So we've got 7 zeros and then the 1. So this would be correct, right? This is the binary representation. Is the 8th bit from the right is turned on. That says that we care about that particular layer. The reason you do it this way is because you could tag multiple layers. There we go. We want these 4 layers are the things that we actually want to raycast against and see if we hit, right? So you turn them on and off like flags, which is great. Now, you don't write the binary like this. The easiest way to do this tends to be something like, we're going to take the number 1. Now, obviously, an integer with the value of 1 looks like this. Then we want to take that 1 and shove it over by 7 places. So what this does is it goes 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It shoves it over by 7 places, which gives us the result that we want. The 8th bit, remember indexing and things like that, is now set in this layer mask. Now, we're not going to hard code in this value because that would be insane. Instead, we probably want to have a public int layer ID for HexTiles. Obviously, this is not what we're going to use. Well, I say that. This is exactly how I name a lot of my variables, so you might think it is. So we could have it as a public here, right? This is our mouse controller, which is just a game object. Oh, we've got a compilation error, so... Oh. The layer mask in there. Do you compile now? Oh. You need to return something. Hang on. Return null for now, just so that it compiles. Actually, that return null will probably still be there. There we go. Okay, so now we can put in the layer ID for the HexTiles, and if we know that we want layer 8, we can punch that in there, and that starts to work okay. And then, yeah, so here it's layer ID for HexTiles -1. And as far as I know, this would work out fine. I mean, I guess we could do a test. Here, debug.log, so hit info dot collider dot name. There we go. So we'll just debug something like that, and then we need to call mouse to hex. I guess we can probably call it every single frame, or where's my click? Oh, right over here. I guess we'll just do it here. Mouse to hex. Okay, so when we lift up the button, we'll do the Raycast and see what happens, which is actually kind of correct. Oh. Or not. I might have the layer mask wrong. We're not going to use it like this anyway. I found nothing. Why for did you find nothing? It's clearly the hex tile. You got the mesh collider on there. We should be raycasting the right way. Let me get rid of that for a second and see if we've made an error with the masking code. I did make an error with the masking code because now we are getting the hex model. Bah. You don't get rid of the -1, is it? Is there, like, is the indexing a little different than I expected? Well, it's possible. Well, heck it is. So the -1 was incorrect. Am I remembering the bitwise operators wrong? So you're telling me that the correct answer here is 1 followed, that's been shoved over 8 tiles. And wouldn't that end up with 1, 2, 3, 4? So 8 zeros over here, so it's sort of the 9th bit that's set? Internally, Unity might be doing something slightly different. The reason that I'm slightly confused about this is because you don't tend to do this manually, because it's kind of annoying. Instead, Unity has a really nice helper for you. Instead of asking for an int over here, and we feed in the number 8 to this layer ID for HexTiles, which is awkward and annoying, instead of doing that, we are actually going to use the layer mask type. So the layer mask type is just a really handy-dandy little helper function that does a couple of things. So this is going to result in an error over here. So let me just comment this out so that we get it to compile. Okay, so this should compile. So mouse controller over here, if you look at the inspector, you have this nice little pull down here to help you choose layers. We can say, we want to choose all the layers. We want to choose none of the layers. We want to choose, how about just the hex tile layer over here? It's got a great little built-in UI element to do that. It lets you pick multiple layers. Whoops. So water and UI. There we go. So now all 3 of these layers would be okay. So obviously that's not what we want here, but it's a very handy-dandy little way to select things, and it's got a handy-dandy little built-in way to get you your layer mask. So we've got our, what do we call this thing again? Layer ID for HexTiles. I guess I'm going to leave that function name in there, even though it's super mega awkward. So you can get the value out of this. Converts a layer mask value to an integer value. And I believe this will be the integer with all the flags set correctly. So we're going to test here, because we did indeed set this to say, hey, I want to collide with HexTile, and we convert that layer mask to an integer. So if I click, there we go, we're getting our hex models over here. And that's a great way to do it, because you can filter multiple things. You can say, I want everything except something. That's fine. But we're just going to set it to that. And there we go. So now we've got our collider working. We're hitting a collider. What we're not getting from this yet is the actual hex. We're going to put a cut in here because this video has gone on long enough. It's very easy for us to convert from a game object to a hex, and then return that. And then what we're going to do is feed that into our pathfinding system and draw a pretty little line along the way. Thanks for watching, folks. See you next time. Hey, I want to say a great big thank you to all the June Patreon supporters and these Mic Check supporters. We've got Yukofin, Eric Sumner, Tiburon, Mighty Mix, Pavel Zdanov, Drazion, Michael McClintock, Aaron Toyson, Craig Mortel, The Not So Evil Engineer, Julien Auger-Lafont, Marius Fieldvold, Speedy Savant, Valiant Cakefiend, Thomas Oberson, Jason Yanity, Stephen Bonnerman, Kale the Quick, and Neil Blakey Milner, and absolutely everyone who watches, shares, favorites, and subscribes to these videos. Thank you so, so much.